Hi, this is Sandana Swami, Assistant Professor of Computer Applications, Bishop People College, Trichy. Here I am going to explain how to solve the problem of 8 queens using backtracking method. Continuing with the backtracking, start with the sub-solution, check if this sub-solution will lead to the solution or not. If not, then come back and change the sub-solution and continue again. This is the normal working procedure of backtracking. Now we will go into the 8 queens problem. Now let us see how to solve the 8 queens problem. What is 8 queens problem is? Here you have got 8 rows and 8 columns. We have to place the queens in each column with the condition that no two queens share the same row, same column or the diagonal positions. In other words, no queen threatens the other queen. If I place a queen in this first position, I cannot place the second queen in the same row. In the similar manner, I cannot also place the second queen in the same column, or I cannot place the other queen in the diagonal position. To make it simple, if I place a queen here, I cannot place any other queen in the first column. The same way, I cannot place any other queen in the first. For our understanding, we shall try to solve this problem using 4x4 board. That is, we have 4 columns and 4 rows. Here we have to place 4 queens with the condition that no queen should threaten the other queen. We can place the queen in any arbitrary position, but we shall start with the first column and we check whether this is a safe position for the first queen, and we find that there are no other queens in the board, so this is a first place and this is a safe place too. So we can leave the queen in the first position itself. Now we shall try to place the second queen in the second row. I cannot place the second queen in the first column because this is a threatening to the first queen. So I cannot place the queen here. Now let us try to place the second queen in the second row. I cannot place the queen in the first column because there is already the first queen in the first column. So I cannot place it here because this is a threatening to the first queen. Let us try to place the queen in the second column. Here also there is a problem because this is threatening to the first queen in the diagonal position. So I cannot place the queen in the second position. Let us try to place the queen in the third column. Let us check whether this is a safe position. So I think this is a safe position because there are no other queens in the threatening position. Now let us move on to place the third queen in the third row. The first position is not a safe position because there is already a queen in the first column. This is also not a safe position because this is threatening to this queen in the diagonal position. Let us try to place the queen in the third column. I cannot place. This is very explicit. We can find the threatening queens. Let us try to place the queen in the fourth column. There is a problem. This is threatening to the second queen in the diagonal position. So we find that we cannot place the third queen in the third column because there is always a threatening position for the third queen from the first queen or the second queen. So here comes the backtracking method. What we have to do here is go to the previous position and try to take the queen to the next position. That is, take the second queen and move to the next column and find whether this is a safe position. I think this is a safe position because there are no other queens which are threatening to this queen. Now we come to the third queen. We try to place the third queen in the first position this is not a safe position because we find that there is already a queen in the first column. Move on to the second position. We find whether this is a safe position for the third queen. I think this is a safe position because no other queen in the same row, same column or in the diagonal position. Now we move on to the fourth queen. We try to place the fourth queen in the first position. Very explicit. There is already queen in the first column. We cannot place the fourth queen in the second column. We find that there is already a third queen in the same column. Move on to the third place and we cannot place it here. We find that there is a threatening queen in the diagonal position. Also we cannot place it in the fourth place and we find that there is a queen in the fourth column. So once again we have to use the method of backtracking. Go back to the previous step and move the queen to the next position. That is, come to the third row, take the queen to the next position. So take this queen to the next position and find that whether this is a safe position for the third queen, and we find that this is not the safe place because there is a queen diagonally threatening to this queen. So what you have to do? Take this queen and move to the next place and we find that already there is a threatening in the same column. So once again we have to use the method of backtracking, means go back to the previous place or previous step and move the queen to the next position. If you go back in the second row, we have already crossed all the columns and we have come to the last column. So what we have to do here, no other way, go back to the previous step and try to move the queen to the next place. It means now we cannot do anything with the second row. Move to the first row and take the first queen to the second place. So here we cannot do anything. Go back to the first row and take the queen to the second column. So and we find that this is a safe place because there are no other queens in the board. Now take the second queen, try to place it in the first column. Explicit, there is a diagonal threatening. Go back to the go to the second column. Yes, once again there is a threatening, we cannot place. Go to the third column. Here also there is a problem, diagonal threatening, and try to place it in the fourth place. I think this is a safe place for the second queen. Now let us try to place the third queen. So is the first place safe? Yes, I think this is a safe place for the third queen. There is no diagonal threatening as well as there is no column wise or row wise threatening for the third queen. Now let us try to place the fourth queen in the fourth row. Is the first place or is the first column safe? I think no, because there is a queen. Is this okay? No, because it is diagonally threatening. Is this place safe for the fourth queen? I think this is a safe place because no other queens are threatening this queen. So now we have placed all the four queens in the board and the condition is satisfied where no queen threatens the other queen. It means that no other queen is in the or two queens are not in the same rows, same columns. So here we have achieved our solution where we have placed all the four queens in the board. This can be easily converted into a program through a very simple algorithm where we use a two-dimensional array. Already we know that the first column is represented with 0, 0 index and 0, 1, 0, 2, 0, 3, and the second row is 1, 0, 1, 1, 1, 2, 1, 3, and third row 2, 0, 2, 1, 2, 2, 2, 3, 3, 0, 3, 1, 3, 2, 3, 3. So this problem can be easily converted into a program using a two-dimensional array. Here this is a first dimensional index and this is a second dimensional index. So this can be easily converted into a matrix.